Okay, so this is the second part of your packet. You should have already turned in 1-1 through 1-4. Anything not turned in by the end of the day is worthless to you, I guess. So starting on page 41 is where this takes off from. It's expected that your voice is off right now. That you have this packet in front of you, that you're not carrying on talking. Your Chromebooks do not need to be open any longer. That way your focus is here. Okay, so this here, let's share screens here. Course 2. We're gonna launch 1-5. Remember, a lot of the launch is not included in your packet. So this is really just for you to be introduced to it, for you to try and understand why we're doing it, what we're doing, right? If you guys can't keep your feet to yourself, I suggest we move apart. Okay?
Yeah, guys, move apart.
At top speed, one of the fastest elevators in the world travels 45 miles per hour. That's a pretty fast elevator.
Will keep their toes in the
The equation, guys, we're dealing with equations now. What do you hear when I say equation? Equals. Something equals something else. Y equals 45x can be used to find the miles Y traveled in X hours. So now with our proportional relationship, Julian, we're talking about equations with it. Okay? Don't we have something times something else? So it should be going at a constant rate. All right, so suppose you ride an elevator up for 1 minute as it travels 45 miles per hour. How could we use the equation y equals 45x to find the distance you will travel? Well, x is per hour. So how many hours would be 1 minute? So 1 out of how many minutes in an hour? 1/60th times how many per hour? 45. That's how we would use that. So those of you who are able to think through that will be successful. Others of you may need to go back and review in order to be successful with this section. All right, so here's our new I can statement. I can write equations, it's right at the top of your packet now. I can write equations to represent proportional relationships and identify the constant of proportionality in the equation representing a proportional relationship. So, and y equals 45x, what do you think the constant of proportionality was? What was constant? X and y might change, but 45 was our constant of proportionality there. Math and science are very interconnected, right? All right, 7th graders. I can make connections between the unit rate and constant of proportionality and how it is represented in the equation. We just talked about it. What and y equals 45x is the constant, Tanner? We're here. You're somewhere completely else. Please turn off the talking, Julian.
I'm an owl.
So, and y equals 25x, our constant of proportionality is that number. It doesn't change, it's constant. Model with mathematics, so I can model a real world proportional relationship with an equation. That's what they just did for us, right? They talked about an elevator going at 45 miles per hour, and they modeled it with an equation.
Oh.
And we can accurately write and solve equations using variables with proportional relationships. Okay. Here's your vocab. I don't know if they wrote anything on there like they usually do. Proportional relationships. So nothing new. What does it mean when there's a relationship between two quantities? How would we determine if they're equal or proportional? we talked about unit rates, right? So if we turn them into the unit rate, they should be equal or equivalent ratios. So proportionality has to do with factors, right? We should be able to multiply one by something to get the other something. What's a portion? How would you define that? Tell your neighbor real quick. How would you define a portion?
What? Equal it.
A part, or
No,
some
you're
some
not.
part that you think to be equal. Like if I'm talking about dinner and I'm giving you a portion of something, I'm giving you a part of it. I'm not getting any of your dinner. All right. How are equations of proportional relationships? Those differ. How do they? How do they differ from non-proportional relationships? Well, what were we seeing? When there was a fee, we were writing out that equation, we would have something times it, right? It always was like per hour or per day or per month or per minute. And then we would do what to it? They added on a fee. So will we see addition in our proportional relationship? No, we won't. But with our non-proportional, we probably will. Don't you agree? Totally.
I have 7.
All right, so let's click this launch. Here comes the balloon. This is how long it's taking to get that far. Okay, and would you say this is proportional? It started at 0, 0, and it looks like it would be a straight line. So let's look at the equation. Y equals 0.345x. Okay. So let's look at the next one. Let's launch this balloon. Are you ready? Where's it starting at? So right away, is it going to be proportional? No, because it has to start where? 0, 0. So let's launch this balloon. It's starting at 10. So couldn't we say that 10 is being added on to it? So let's look at this equation now. Still going. So see how they added on? See the difference between the proportional and the non-proportional? Non-proportional, they were adding on. It started not at 0, 0. All right, let's launch this balloon. Is this possible? It's possible. It's starting at 0, 0, so it. It looks pretty proportional. Let's see. Yep, looks good. Nothing was added on. All right, so if we had to align these with what was proportional and what was non-proportional, anything with an addition sign would be labeled as non-proportional. So, is this proportional? Yes, that was one of our equations. Is this proportional? No, it has an addition sign in it. Is this proportional? Yes. All right. So how are equations different from those non-proportional? Well, we talked about how we added or started at a different point, right? I know, did you want to know? Wendy baby left that in here last night. All right. Okay, questions about proportionality as far as equations? So we can move on to learn a little bit. Are you ready? This is on page 41 where it says learn. It follows along with these slides. two quantities are proportional, says it right in your packet, if the ratios comparing them are equivalent. Remember, we tested for equivalency by finding unit rates. We're simplifying. This ratio is called the constant of proportionality. Remember, our constant of proportionality was equal to our unit rate. Proportional relationships can also be represented by an equation in the form y equals kx, where k is the constant of proportionality. So here's your words. A linear relationship is proportional when the ratio of y to x is a constant k. That's written there for you. You don't have to write anything there. With symbols, y equals kx, where k equals 0. That's also written there for you. Here is your example. Y equals 3x. What is the constant of proportionality? What does k equal and y equals 3x? What is k? If our equation is y equals kx, and the example is y equals 3x, what is k? 3. So k equals 3. 3 is our constant of proportionality. All right, they also give you this graph here. They're graphing it for you. Let me move this out of the way. That is that. All right. Are we good on page 41? Any questions there? So can you write an equation in the form y equals kx for a line that does not pass through the origin? Is that possible?
My dog has a nail on him. Yeah.
Well, if I put 0 in for x, what will y always equal? 0, because anything times 0 is 0. So that talk about it is no. Y equals k times 0. Anything times 0 is equal to 0.
I don't know what they call it a funny bone, because when you hit it, it's not funny.
It's not. Okay. Oh, man. All right. We have just a few minutes. I need your focus now.
Maybe it looks funny.
Olivia bought 6 containers. Let me zoom out a little bit. Of yogurt for $7.68. The equation y equals 1.28x can be used to represent this situation where y represents the total cost of the yogurt and x represents the number of containers bought. So what is my constant of proportionality?
I'm sorry.
What is the constant of proportionality? K is,
I'm a little messed up.
what's K?
Oh, my.
What's in front of my X?
K is still 1.
1.28.
Chelsea, you're so smart, Matt.
So that means that the constant of proportionality has the same value as the unit rate. And what was the unit rate? Each container of yogurt is what? $1.28. So in this check here, what is the constant of proportionality? What's in front of X? 195. And what does 195 mean? It's a unit rate. So which one of these has 195 as a unit rate? The last one. It's saying an airplane goes at 195 miles per hour. All right, finally, I want you to jump ahead to page 47. Page 47. Both of these, numbers 1 and 2, wants to know what is the constant of proportionality and what does it mean? Well, what is K here? What is K here? Do you guys hear that? These are ones you should understand and be able to practice on your own. You should know that 4.75 is our unit rate. So if she's doing this for 2 bracelets, how much is each unit? She's earning $4.75 per bracelet. So this means $4.75 per bracelet. So we do have to do a little bit of reading into things for number 2 when we're figuring it out. So total time, so how fast are we going? All right, and that's number 2. So make sure you're practicing those on your own. 1 minute.
It's actually 10 seconds. No, it's 10 seconds.